Once again, welcome to another edition of Subject Matters. Don't forget to like, share with your friends, and subscribe to this video. Thank you. Today, we will solve past questions. UTME, WAEC, NECO on refraction of waves. I believe you're ready, so let's get started. The refractive index of the medium in N. Here's the diagram. We are asked to find the refractive index. Recall that refractive index is equals to sine I over sine R. Sine R is equals to the sine of incidence over sine of refraction. So we have sine of reflection. So our I, which is the angle of incidence, is the angle between the normal and the incidence ray. If this is 30, then this rate will be 60 degrees. Since here is 90 degrees, perpendicular, 60 plus 30 will give us 90. So our high is 60 degrees. And here we have the refracted ray to be 60 degrees. So we put this into our formula, which is sine 60 over sine 30. Sorry, the refracted ray is the angle between this rays, the normal and this, which is equals to 30 degrees. So sine 60 over sine 30 will give you 1.732. In short form, I can write it as root 3. So the refractive index of this medium is 1.732 or root 3. Now, the horizontal flow of a water reservoir appears to be this when viewed from above. The refractive index of water is this. We are asked to calculate the depth of the reservoir. Okay? So we have the apparent depth. Apparent depth. It appears to be. Apparent depth is 1 meter, to be 1 meter. The refractive index is 1.35. And we have to find the real depth. The real depth. We don't know. You recall from that same formula that refractive index is equal to real depth over apparent depth. Now, by the time we make the real depth the subject of the formula, we have real depth is equals to refractive index times the apparent depth. And that will be equals to 1.35 times 1. That's 1 meter. We have 1.35 meters. So the real depth of the reservoir is equals to 1.35 meters. So we have another question here. A ray of light is incident at an angle of 30 degrees. That's the incident angle. At an air glass surface, air glass. So we are asked to draw the ray diagram to show the deviation of the ray. So this is what the ray diagram looks like. This arrow signifies the angle of incidence, which is 30 degrees. As it passes through the glass, it is refracted this way. So between the refracted ray and the normal, we have our angle of refraction, and here we have our angle of deviation, as you can see. So the second question says determine the angle of deviation if the refractive index is this. So you recall, angle of deviation. Angle of deviation is equal to I minus r. Angle of incidence minus r. From this question, we have our incidence, but we don't have r. So let's go ahead and find our r. We also recall that refractive index equals to sine r, sine I over sine r. So if we make sine r the subject of the formula, we have sine r is equal to sine I over this, the refractive index. So sine I is equal to, our height is the incidence, which is 30. The refractive index is given 1.50. So if we multiply this, we have 0.333. So sine r is equal to 0.333. But we need to get our r. So r is therefore arc sine 0.333, and this will give me 19.3 degrees. So the angle of the refracted angle is 19.3 degrees. So let's come back to this formula. We are asked to find the angle of deviation. So we have angle of deviation is equal to I minus r, which equals to 30 degrees minus 19.3 degrees. And that will give me 10.7 degrees. So our angle of deviation is equal to 10.7 degrees. So question 4. Radio waves travels in air at 3 times 10 raised to the power 8. We are given the refractive index, and we are asked to find the speed of the radio waves in water. Okay, so you recall that refractive index from air to water is equal to velocity of the wave in air over the velocity in water. Okay, so we have 4 over 3 is equal to velocity in air is 3 times 10 raised to the power 8, and the velocity in water we don't know, so I'm going to put my v. So if you cross multiply, we have v, and make v the subject of the formula, so I have v is equal to 3 times 10 raised to the power 8 all over 4, and this will give me 2.25 times 10 raised to the power 8 meters per second. So the velocity is equal to 2.25 times 10 raised to the power 8 meters per second. The velocity of the wave in water. The next question says calculate the critical angle. We are given refractive index. So to find the critical angle, you recall that sine C, which is the critical angle, is equal to 1 over refractive index. And that will be equal to 1 point this. So we have sine C is equal to 1 divided by 1.33 will give me 0.752. So to find the C, which is the angle, we have arc sine 0.752, which equals to 48.76 degrees. So the critical angle is equal to 48.76 degrees. Here is question 6. We are given that a rectangular glass prism of 6 centimeter thickness, refractive index 1.5, and we are asked to find the apparent upward displacement. We are asked to find the apparent upward displacement. Now, to do that, we need to find our real vector. We need to find our apparent depth. Sorry. So we are given the thickness, which is equal to the real depth. So we need to find the apparent depth because upward displacement is equal to the real depth minus the apparent depth. So we have the real depth, but we don't have the apparent depth. So to do that, apparent depth is equal to real depth over refractive index, and that is 6 over the refractive index is 1.5, and this will be equal to 4 centimeters. So our apparent depth is equal to 4 centimeters. Now to calculate the apparent upward displacement, apparent upward displacement is equal to real depth minus apparent depth. So the real depth is 6 and the apparent is 4 centimeters. 6 minus 4 is equal to 2 centimeters. And that is equal to the apparent upward displacement. Now the next question here says, a ray of light experiences minimum deviation when passing through an equilateral triangular prism. Now note, the angle in an equilateral triangular prism is 60 degrees. So we have our A is equal to 60 degrees. And then we are given our refractive index, which equals to 1.5. Now when A is 60 degrees, there's a formula that says angle of refraction is equal to A over 2, which equals to 60 over 2. So we have our angle of refraction. The question said, calculate the angle of incidence. Given these parameters, we have to find the angle of incidence. Now we have this formula that says sin I over sin R. So this is the formula connecting them. Therefore, angle of incidence is equal to refractive index times sin R. So we have 1.5 times sin R, that's 30 degrees, which equals to 1.5 times 0.5. And this will give me 0.75. So sin I is equal to 0.75. I therefore is sine inverse of 0.75, which equals to 48.6 degrees. So the angle of incidence of the ray is equal to 48.6 degrees. A thin converging lens has the power of 4 diopters. Calculate the focal length. So you recall that P is equal to 1 over focal length. So also F is equal to 1 over P. So from the question we have P, which equals to 4. So our focal length is equal to 1 over 4, and that is equal to 0.25 meters. It's that simple. Now the next question says the converging length of focal length is 15 centimeters, forms a virtual image at a point 10 centimeters. Now because this is the image distance, V is 10 centimeters, but because it is a virtual image, so it's going to be negative. Virtual image is negative for converging length. Now calculate the object distance. We are asked to find U. So you recall our formula that says 1 over F equals to 1 over U plus 1 over V. So we are looking for U. So we make U the subject of the formula, and that will give us 1 over U is equals to 1 over F minus 1 over V. And this will be equals to 1 over F is equals to 1 over 15 minus, so we have minus 1 over 10. So minus times minus will give us plus. So I have 1 over 10. I want to believe that is clear. So this will be equals to 1 over U is equals to 5 over 30. So to get U, I'll turn it the other way. That's the inverse, the reciprocal. Then I have 30 over 5, which equals to 6 centimeters. 6 centimeters. Last question here says calculate the angle of minimum deviation for a ray which is refracted through an equiangular prism of refractive index. So we have refractive index equals to 1.4. A, because it's equiangular, so we have A to be 60 degrees. We are asked to find the angle of minimum deviation. So you recall, angle of minimum deviation, we have this formula connecting refractive index with angle of minimum deviation. Sine half into bracket A plus D minimum. This is the angle of minimum deviation over sine half A. So I'm just going to input the values. I have 1.4 here is equals to sine half A is 60 plus D minimum all over sine half times A, which is 60. So from here, 1.4 is equals to sine half 60 plus D minimum, which is the angle of minimum deviation, over sine half times 60, that will give me sine 30. So I have 1.4 is equals to sine half 60 plus D minimum over sine 30 is equals to 0.5. So I'm going to cross multiply. By the time I cross multiply, this is what I have. I'm going to have 0.7 is equals to sine half 60 plus D minimum. I want to believe it's clear to that level. So sine 0.7 is equals to half times 60. How did I get this half sine? I divided both sides by sine. So I have half sine 0.7. By the time I divide this side by sine, I am left with half into bracket 60 plus D minimum. So if I expand the bracket, I have half times 60 plus half times D minimum. So sine inverse of 0.7 is equals to 30 plus D minimum over 2. I want to believe this is clear. So we have 44.4. Sine inverse of 0.7 will give me 44.4 is equals to 30 plus half D. Okay, so I have 44.4 minus 30 is equals to half D. And this gives me 14.4 is equals to D over 2. So by the time I cross multiply again, I have 2 times 14.4, which equals to 28.8 degrees. So my angle of minimum deviation is equals to 28.8 degrees. I believe that is very, very clear and well understood.